Here we have a quadric surface, which is typically kind of difficult to draw, but we'll start with the usual approach, which is to look at traces. I'm going to start with the xy trace. It's defined by z equals 0. I set z equal to 0. Oops, that should be a minus. And I'm going to move things around to get x squared minus y squared equals 1. That is a hyperbola. It has x-intercepts. The x-intercepts are 1 and -1. It does not have y-intercepts, because if I let x be 0, I get negative y squared equals 1, which of course has imaginary solutions. So this hyperbola, one branch opens forward and the other backward. Okay. Now let's take a look at, let's say, the YZ trace. Set x equal to 0, and we get z equals 1 plus y squared. That's a parabola. The vertex is y equals 0, z equals 1. And it opens upward in the YZ plane. So it's going to go kind of like this. And then let's see what else. We've got, well, we haven't done the XZ trace. Defined by y equals 0. So I set y equals 0. I get z equals 1 minus x squared. That's in the xz plane. Now that is a it's also a parabola. Its x-intercept is 0, its z-intercept is 1, so it's the same point. But this one opens downward, and it's in the xz plane. It's actually going to pass through these points here. If you look carefully, you'll see that the x-intercepts of this parabola are 1 and -1. So, what exactly are we looking at here? Well, if we go a little bit higher, which I think is necessary, say to the z equals 2 trace. So 2 equals 1 plus y squared minus x squared. That says 1 equals y squared minus x squared. Now remember, we're in the plane z equals 2. So let's say this is 2 right here. So I'm going to draw a line parallel to the x and a line parallel to the y. We're in that plane. In that plane, this represents a hyperbola. The y-intercepts are 1 and -1. So here's y equals 1, here's y equals -1. Translate those upward. Those should actually connect with the parabola that I just drew here. You could verify that if y is equal to 1. Where is that? It's right here. When y is 1, z is 2. When y is -1, z is 2 as well. So that's correct. As I said, the y-intercepts are 1 and -1. There are no x-intercepts, because if I let y be 0, then I get x squared equals -1, which has imaginary solutions. So there's a hyperbola here. As I mentioned, one branch opens to the right and the other to the left. We got a lot going on here. But I think we can piece it together now. So the top part of this cutting it off here, and the plane's equals to. The top part consists of these hyperbola, well, it's a hyperbola, 2 branches. And then this thing dips down. And then you got this parabola here. And then below that, there's this other hyperbola. Now this bit back here is kind of hidden from view. But basically what we have, I wish I had drawn this hyperbola a little bit wider. I guess I can do that. Make it wider. So what this looks like is, as I said, if this came out a little bit wider, this would make a whole lot more sense. So let me see if I can, there we go, widen it up. What this looks like is a saddle. Let me see if I can connect everything together. Like I said, if this were wider, the connection would be clearer. So think of it this way. It's a saddle in the sense that if your butt is sitting right here, maybe you're facing this way, so you're facing forward. Saddle comes up in front of you, and then it comes up behind you, or comes down, depending on your perspective. And then your legs hang over on either side, right? One hangs on this side, the other hangs on this side that we can't see. This is an example of a quadric surface called a hyperbolic paraboloid. And the typical picture that you would see of a hyperbolic paraboloid is something that looks like a saddle.